What is up, mathematicians? And today we are going to be talking about word problems involving fractions and using all of our strategies and skills we've learned so far to solve it. Before we get into practicing our problems using our problem set questions today, we're going to be doing a review activity first. But before we get into that even, let's do our I will statements. Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these three things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary. All right, mathematicians, let's go through our I will statements for today. Listen first. I will draw information from the word problems. Read it with me. I will draw information from the word problems. Good job. Number 2, I will multiply fractions. Read it with me. I will multiply fractions. And our last one, I will compare my solutions to different solutions. Read it with me. I will compare my solutions to different solutions. That last one has to do with comparing our answers to how other peers solve the problems. Sometimes there's more than one way you can get to the same answer, and it's always good to see how your peers solve it because maybe there's a faster way or another way that you can learn to get to the same answer. Now, before we get into our activity and our word problems today, we're going to do a little activity to get warmed up. For our activity today, we are going to be playing something called the fly swatter game. I'm going to show you an answer or a problem in the middle of the board. The problems that appear will have answers floating all around them. Your job is to find the correct answer as fast as possible and get your hand on the answer. If you get your hand on the answer quick enough, then you get to stay at the board. If you are not the first one to get your hand on the board quick enough, you go take a seat and the next person comes up. To win the game, you want to stand the longest and beat out as many classmates as you can. It can be your time at any moment, so make sure you pay attention. And when you're not playing, make sure you take time to look at the board to see where the answers are so you can help find them faster when it's your time up there. Now we're going to take some time and we are going to get ready for our problem set questions. Get your problem set pages out and get ready with a pencil. We're going to read problem 1 together. Tamika ran 2 5/8 miles. Her sister ran twice as far. How far did Tamika's sister run? To start with this problem, we're going to start off by using the information in the problem to help us draw a picture, and then we're going to work on 2 different ways that we could solve this problem. Remember, one of our I will statements for today is I will compare my solutions to other solutions. So it's good to know 2 different ways to approach a problem using the strategies that we have learned so far to find which one fits you best. Now, looking at the information in our problem, it's always smart to start with a picture. We know how far Tamika ran. I'm going to put a T for Tamika. In our problem, it told us that she ran 2 5/8 of miles. 2 5/8 miles. So I'm going to write that up top. Let's take 2 5/8 and break it up into the whole number and the fraction for our picture. So we have 2 as our whole number and 5/8 as our bottom number. Now, we know that Tamika's sister ran twice as much as Tamika did. So I'm going to take how much Tamika ran and I'm going to draw that twice for her sister. So she ran, my box was a little wonky, 2 5/8, but she did it 2 times. So I'm going to draw another box and 5/8. Now, there's different ways that we can solve this problem. When I originally look at this problem, one thing that I see is we have 2 groups. We're trying to figure out how much Tamika's sister ran, remember? I see that we have 2 groups of 2 5/8. So that's 2 times 2 5/8. Make sure you're writing this on your problem set pages. Now, 2 times 2 5/8, we broke 2 5/8 down to 2 plus 5/8. So I'm going to break my multiplication problem down a little bit more. I'm going to take my 2, and we broke down 2 5/8 to 2 plus 5/8. I'm going to push my board up a little bit here. So I'm taking this problem, and this is the same thing as saying this. We're just breaking it down a little bit more. Now, one of the properties we have talked about when using different pictures like this is the distributive property. We're going to take the 2 or the number of groups we have and distribute it out to the whole number in our mixed number and the fraction in our mixed number. So now we have 2 times 2 plus 2 times 5/8. So now if I was going to solve this problem, everybody, what's 2 times 2? Good. 2 times 2 is 4. And what's 2 times 5/8? Remember, the 2 as a whole number has an invisible 1 on the bottom, so just multiply across. 2 times 5 is 10. 1 times 8 is 8. Now, 10/8 is an improper fraction. I know I can see that my numerator is bigger than my denominator. So let's change that into a mixed number really quick. We'll leave the 4. 8 can go into 10 one whole time. I'm going to leave my 8 as my denominator. We need to figure out our numerator. 8 times 1 gets us 8. How many do I have to count up to 10? 9, 10. I had to count 2 up to 10. Now I have a whole number plus my mixed number. 4 plus 1 2/8 equals 5 2/8. So we can say that Tamika's sister ran 5 2/8 mile. Now, this isn't the only way we can solve this problem. This is using the distributive property to help us solve the problem. But is there another way to do this problem and still get the same answer of 5 2/8? What if we looked at this problem like an addition problem? What if I saw my 2 5/8 plus another 2 5/8? If I saw it like this, couldn't I break my fractions up so I had 2 5/8 2 and 5/8, not keeping them together and just adding them this way. So let's add our whole numbers first. What's 2 plus 2? Good. 2 plus 2 is 4. And if we had 5/8 plus 5/8, they have the same denominator. So I leave that the same. What's 5 plus 5? Good. 5 plus 5 is 10. We saw this fraction before, right? We know that 10/8 is the same as 1 and 2/8. Let's bring down our plus 4. Now, if we add this whole number and this mixed fraction, do we still get the same answer? Yeah, we still get the same solution of 5 and 2/8. Let's write this in a sentence. Tamika's sister ran 5 and 2/8 miles. So we were able to use two solutions. We used our distributive property to help us solve this problem, and we also were able to break our mixed numbers up into the whole number and the fraction and add up the two separate parts before combining them back together and getting the same answer. You guys are going to go through the rest of the problem set questions. Make sure you compare your solutions with a partner. Did your partner solve it differently? If they did, write down how they solved the problem too for memory and to look back on these notes in the future. Good luck, mathematicians, and I'll see you guys soon.